Chain structures. In this video, we will discuss open chain structures of alkanes, alkenes, alcohols, carboxylic acids, esters, and halogenoalkanes. We will do examples of structures with one functional group attached to a chain of carbon atoms. First, have a look at the list of homologous series included in the A-level chemistry syllabus. Where the series alkane, alkene, halogenoalkane, alcohols, carboxylic acids, and esters are included in O-level and IGCSE syllabi too. The table shows the name of the homologous series, functional group, structural formula, displayed formula, skeletal formula, and name of the compound. The third column from the left shows the structural formula of the functional group that gives the general formula of homologous series, where R represents any chain of carbon atoms or hydrogen atoms. Alkane is not shown in the list because it has no functional group. The table shows the open chain and ring structures. Can you see the types of covalent bonding in the compounds given in the table? If you look carefully, you can see single, double, and triple bonds. Let's discuss first why carbon is showing all three types of bonding whereas hydrogen can only form a single bond. Carbon needs 4 electrons to complete its octet by forming 4 single bonds, 2 single and 1 double bond, 2 double bonds, and 1 single and 1 triple bond. Hydrogen needs 1 electron to complete its duplet by forming a single bond. Nitrogen has 5 outermost electrons and to complete its octet, nitrogen can form 3 single bonds or 1 single and 1 double bonds or 1 triple bond. Oxygen has 6 outermost electrons and to complete its octet, oxygen can form 2 single bonds or 1 double bond. Halogens, group 7 elements, have 7 outermost electrons and to complete their octet they form 1 single bond. Ways of drawing structures of organic compounds. Displayed formula. Structural formula. Skeletal formula. The displayed formula shows all the atoms and bonds between atoms in a molecule. The structural formula shows how atoms are arranged in a molecule, but no bonds are shown between the atoms. The skeletal formula shows a carbon skeleton with a functional group attached. The line shows the type of covalent bond, and each corner of the line represents a carbon atom. Hydrogen atoms are not shown in the skeletal formula. This screenshot is showing a question about O-level chemistry. If you read the question thoroughly, you will get a clear idea of drawing the structure. First, the name of the homologous series, which is alkene, shows that 1 carbon-carbon double bond must be present. Second, unsaturated hydrocarbon shows only carbon and hydrogen atoms in the compound with a carbon-carbon double bond. Third, show all of the atoms and all of the bonds, means you will draw a displayed formula. We will discuss unbranched and branched structures in the isomerism topic. Let's see how the formulae of organic compounds can be drawn using the name of homologous series and functional groups. Alkane has no functional group and is called saturated hydrocarbon, only carbon and hydrogen atoms with carbon-carbon single bonds. In alkanes, carbon forms a single bond only with other carbon atoms and hydrogen atoms. In the displayed formula, all the atoms and bonds are shown. In the structural formula, only the atoms attached are shown. No bonds are shown in the structural formula. To draw skeletal formula, 2 or more carbon atoms are required for hydrocarbons. Let's take another example with 2 carbon atoms. Attach the carbon atoms with single bonds, as they are alkane compounds, then complete the octet by showing a single bond with hydrogen atoms. Because alkane is saturated hydrocarbon, so only carbon and hydrogen atoms with carbon-carbon single bonds. And now we also know that hydrogen forms a single bond because it needs to complete its duplet. Each corner of the line in the skeletal formula represents a carbon atom. Now apply the same to 4 carbon atoms of alkane. Alkene has a functional group of carbon-carbon double bonds. They are unsaturated hydrocarbons, only carbon and hydrogen atoms with carbon-carbon double bonds. We will practice alkenes with 1 carbon-carbon double bond. Compounds in alkene start from 2 carbon atoms because a double bond needs 2 carbon atoms to form. If you carefully look, the position of the double bond is the same in all 3 formulae of an alkene with 4 carbon atoms that are between the second and third carbon atoms. The position of a double bond and functional group will be discussed in detail in the naming of organic compounds. Before we move to alcohol, first compare the structure of alkane, which is a saturated hydrocarbon, and alkene, which is an unsaturated hydrocarbon. The same number of carbon atoms of alkene has 2 fewer hydrogen atoms than alkanes because of a double bond between carbon atoms. Alcohols contain a hydroxyl functional group. In the hydroxyl group, oxygen forms 2 single bonds to attain the octet. The oxygen in the hydroxyl group is attached to the carbon chain. Again, we will draw the chain of carbon atoms first, then place the hydroxyl functional group, and last fill it with hydrogen to complete the structure. Let's start with 1 carbon atom, attach the hydroxyl group with this carbon atom, and complete the structure with hydrogen atoms. Now we will draw the formulae for 2 and 3 carbon atoms the same way. In the structural formula, the hydroxyl group in the compound with 3 carbon atoms is attached to a center carbon atom, which is why the hydroxyl group is enclosed in the bracket to show its position. Functional groups like hydroxyl and halo groups, their position in the structural formula is shown in brackets when they are attached to any carbon atom in the middle of the chain. Carboxylic acids. Carboxylic acids contain a carboxyl group. It is a big group and always at any one side or corner of the chain. Draw first the carboxyl group, then attach the chain of carbon atoms to the carbon atom of the carboxyl group. Complete the octet of the carbon atoms in the chain with hydrogen atoms. Halogenoalkanes. Halogenoalkane contains halogen attaches to the chain of carbon atoms. Like if chlorine is attached, it is called chloro, and so on. Let's have the structures of halogenoalkanes with 1, 2, and 3 carbon atoms. Esters. Esters contain ester linkage. Ester functional group is a big group too, like the carboxyl group, but because carbon and one of the oxygens in the ester group need to complete their octet, the ester linkage is in the middle of the chain of carbon atoms. Here are some examples of esters. In esters, there is a carbon chain on both sides of the ester linkage. In the next video, we will discuss some more homologous series. Thank you for watching.